Testing. Components are tested to ensure they meet requirements. Levels of testing include unit, component, system, and acceptance testing. Unit testing is a development process in which the smallest testable parts of an application, called units, are individually and independently scrutinized for proper operation. Unit tests are usually written and performed by developers to ensure code meets its design and behaves as expected. Unit testing should be done before integration testing, and can be done via black or white box testing methods. Component testing. Similar to unit testing, component testing is performed on each individual component separately without integrating with other components. System testing is conducted on a complete, integrated system to evaluate the system's compliance with its specified requirements. Often carried out by independent or specialist testers. Acceptance testing. The purpose of this testing level is to evaluate the system's compliance with the business requirements and assess whether it is acceptable for delivery. Acceptance testing is done by the user/customer. The general testing process. Planning. This establishes the scope of testing, and acceptance/exit criteria. Analysis and design. This is the designing of the test cases. Implementation and execution. Evaluation. Assessing if the testing is complete and reporting of the results. Exit criteria. Exit criteria is used to determine whether a given test activity has been completed or not. For example, verifying that all tests planned have been run. If so, then this exit criteria has been met. When criteria is met, a test summary report will be generated and shared with stakeholders. From this, the decision may be made to go on to a new test level or finalize this as the last testing stage. Why test early in development? Problems that are introduced into the system during design or planning can be caught, and the requirements testing can anticipate future problems at a lower cost. Quality will also be ensured. Test cases written during requirements gathering can be shared with developers and allow them to evaluate more potential problems, reducing the risk of failure in the code. Finding defects. Techniques to find defects can be divided into three categories. Static techniques. Testing is done without physically executing a program. Dynamic techniques. This testing includes physically executing system components to identify defects. An example of this would be executing a test case. Software test cases are a specification of the inputs, execution conditions, testing procedure, and expected results that define a single test to be executed to achieve a particular testing objective. Operational techniques. This is where an operation system produces a deliverable containing a defect found by a user. The defect is found as a result of a failure. Defects can be identified at any stage and by anyone in the development process. In order to ensure a quality product, a defect should be well documented. A report should contain a summary, description, platform or build, steps to reproduce, expected result, actual result, testing vs debugging. Testing is the process of looking for errors, whilst debugging is the process of correcting the error. Black box and white box testing. White box testing involves checking the way that things happen inside the system, aka, looking at the code, meaning it is typically a static technique. Black box testing, on the other hand, involves checking that the output is as expected based on the input. Example. Black box. Insert a coin into a drinks machine, and enter the drink code. If the drink is vended correctly, the test was successful. White box. Open the drinks machine up and check that the money went along the correct verification pathway, and the mixers for the drink were added in the expected sequence. Performance, load and stress testing. Performance testing is a type of software testing that intends to determine how a system performs in terms of responsiveness and stability under a certain load. Load in this instance being how many transitions a system is performing in a given time. Stress testing is a test where the load given to a system is at or beyond that which it is expected to be able to work with under normal conditions. Quality assurance. There are other mechanisms outside of tests to ensure quality. We will explore 4 below. Informal reviews. These are often in the form of peer reviews, such as a developer reviewing the code produced by another developer. A quick and cheap type of review, that helps identify any obvious errors. 2 pairs of eyes are better than 1. However, the review may also not pick up on some errors, as this review relies on humans. It is always open to human error. Walkthrough. In this, the product is walked through line by line or section by section to identify errors. Often particular scenarios are used to mimic live situations. The review can be done by an individual or group, and is more likely to identify errors than an informal review, particularly if it is done by a group. Technical reviews. In this, the product is reviewed by a group of technical experts who usually use checklists of common problems to identify errors. Inspection. This is a formal meeting, with clearly defined roles and objectives. Roles include inspectors. 1 or more inspectors review the product in detail. Scribe. The scribe records all errors, actions, and decisions. Moderator. The moderator is responsible for ensuring that the product is reviewed in a structured manner, conflicts are managed appropriately, and all points of view are accounted for. Implementation. Is moving into the live environment. It takes careful planning, and is often conducted by software release engineers. There are many different implementation methods, such as installing on a user's machine remotely, uploading to an app store, distributing via email, and so on. Generic implementation types. Pilot. The new software is placed on a limited number of machines, and accessible to a small group of users prior to wider use. Strengths. Failures can be identified and fixed without widespread issue to the business. Users have time to get familiar with the new system, and training can be done in pilot groups. Weaknesses. Scale issues may not be detected, as a system may work well for 10 users but not for 200. Parallel. This is where the new system is used at the same time as the older system. Strengths. If there is any issues with the new system, they can be ironed out within a reasonable time instead of rushing, as the old system will still be working. Users can compare the outputs of both systems to ensure they are correct. Users have time to adjust to the new system. Weaknesses. Users must take more time to enter data into 2 systems. There is a risk of data loss as both systems run in parallel. Phased. This is when small parts of the new system gradually replace the original system. Strengths. Training can also be delivered incrementally. A failure in the new system is less detrimental as it is only a small part of the system. Weaknesses. Risk of data loss if new system fails. This method take a long time to implement the new system. Big bang/direct. Is the act of implementing the new system without any phased or pilot implementation. The old system is retired and the new system set live. Strengths. Only a good method of implementation for non-critical systems. Weaknesses. Risk of data loss if new system fails. Users do not have time to get acquainted with the new system. Sign-off occurs when the product is handed to the customer and they acknowledge receipt of the product and completion of the project. This usually includes signing a legally binding document, to ensure the customer cannot claim to not have agreed or received the product, and the developing party may receive payment. Typically sign-off occurs before deployment. Post-implementation reviews, PIR, are conducted at the end of a development. They evaluate the project as a whole, to determine what went well, what didn't, and potential improvements for next time. They can include all members of the project team. An ideal time to do a PIR is shortly after the project has been delivered, and when most of the problems have been addressed, as the project is still fresh in everyone's minds. Maintenance. The development life cycle is not called a cycle for nothing. The development of a system doesn't end when it is released, but rather continues as the system is updated, faults are identified and fixed and improvements are made until, eventually, the system is decommissioned. This is the maintenance stage. Throughout this period, the system needs maintenance and support such as backup, patching, and audits. Support is to help users such as providing training, tips, and helping solve issues, whilst maintenance is about keeping the software product working effectively. Maintenance processes are owned by the IT department, and based upon predefined rules and tasks. Types of software maintenance. Perfective change. 50 to 55% of most maintenance work is attributed to perfective changes. Perfective changes refers to the evolution of requirements and features to an existing system. This is because as a software gets exposed to users, they will think of different ways to expand the system or suggest new features that they would like to see as part of the software, which in turn can become future enhancements to the system. Perfective changes also include removing features from a system that are not effective or functional to the end goal of the system. Adaptive change. 20 to 25% of maintenance work is attributed to adaptive changes. Adaptive change is triggered by changes in the environment the software lives in, such as changes to the operating system, hardware, software dependencies, or even organizational business rules and policies. These modifications to the environment can trigger a domino effect of changes. Corrective. 20% of maintenance work is attributed to corrective changes. Corrective changes address errors and faults in a software. Most commonly, these changes are sprung by bug reports created by users. However, be mindful that sometimes problem reports submitted by users are actually enhancements of the system, not bugs. Preventive change. 5% of maintenance work is attributed to preventive changes. Preventive changes refer to changes made focusing on decreasing the deterioration of a software in the long run. Restructuring and optimizing code and updating documentation are common preventive changes. Executing preventive changes reduces the amount of unpredictable effects a software can have and helps it become scalable, stable, understandable, and maintainable. Types of software support. First-line support. An end user reports a problem. First-line support technicians will log the issue and assign a unique reference number to the issue case. First-line supporters may try to resolve the issue, however if they cannot, they hand it over to second-line support. Second-line support. Second-line support are more technically knowledgeable, and will try to resolve the issue. If they cannot fix it, it is escalated to third-line support. Third-line support. Third-line supporters are typically developers who know a software system. They will almost always solve the issue.